Hello everyone, welcome back to my mathematics channel. As we approach the conclusion of our number and numeration series, we'll be diving into a new topic within this series, percentage error. Today, we'll be reviewing a past exam paper from the KCSE, Kenya Certificate of Secondary Education, covering both Part A and Part B of the question. My name is Adewale King. Sit back, relax, watch, and enjoy the lesson. Don't forget to watch, comment, like, and subscribe to the channel. Check it out! For percentage error, the following formula has to be considered. 1. Error equal to measured length minus actual length. 2. Absolute error is equal to measured length minus actual length. 3. Relative error is equal to absolute error divided by actual error. 4. Percentage error is equal to absolute error divided by actual error times 100. Note, for an approximated measurement, the least unit of measurement is 1, and absolute error of an approximation measurement is equal to plus or minus half of the least unit of measurement. Now let's take a look at this example from the KCSE 2005 question 9 paper 1. It says, in this question, mathematical tables should not be used. The base and perpendicular height of a triangle measured to the nearest centimeter are 6 centimeter and 4 centimeter respectively. Find A, the absolute error in calculating the area of the triangle. B, the percentage error in the area, given the answer to 1 decimal place. Now, let's take a look. To solve this question, we're going to write out the parameters in this question. And it says the base and perpendicular height of a triangle measured to the nearest centimeter are 6 centimeter and 4 centimeter respectively. So we say solution. So the base is 6 centimeter and the height is 4 centimeter respectively. So the question says the absolute error in calculating the area of the triangle. We should find this absolute area, and we know that there should be an error. There should be possible error in the base and possible error in the height. For an approximated measurement, because this is approximated to 6 centimeter. So for an approximated measurement, we can see that the least unit will be 1 and the absolute error will be half or plus or minus half of 1 for this question, which is in centimeter. So that will be plus or minus 0.5. So we're going to add this to base and height because there will be possible error in the base and height. So the base will be 6 plus or minus 0.5 and the height will be 4 plus or minus 0.5, and that means that the base is 6 plus 0.5 will give us 6.5, or 6 minus 0.5 will give us 5.5. And for this, height will be 4 plus 0.5, which is 4.5, or 4 minus 0.5, which will be 3.5 respectively. So to solve this question, to find the absolute error in calculating the area of the triangle, we know that the area of a triangle is half base times height. This is the formula for area of a triangle. Another formula we're going to look at is the absolute error. So the absolute error will be half of the area of the maximum minus area of the minimum triangle. So this will be the formula for the absolute error, and we're going to look at the formula for the area of the maximum, which is this and this are the maximum, and this and this are minimum for each of these variable. So we're going to look at the area for the maximum. Area for the maximum will be half base 6.5 and height 4.5. So that will give us area for maximum will be half times 6.5 times 4.5 should give us 14.625, and that will be the answer for the area for the maximum. And for the area for the minimum, this will give us half times 5.5 times 3.5. So the area for the minimum will be half times 5.5 times 3.5 should give us 9.625 if you calculate that in your calculator, and that will be in centimeter square. That will be the unit of the area. So we're going to look at this and this and put it in our solution, and that will be absolute error will be equal to half of the maximum, that is half, you can say half bracket 14.625 minus 9.625. So 625 minus 625 will be 0. So 14 minus 9 should give us 5. So absolute error is equal to half times 5, and that will give us 2.5. So the next question is to find the second part, which is the percentage error in the area, given the answer to one decimal place. So we'll say that the percentage error, that is the second part, B part, percentage error is equal to the absolute error over the actual error times 100. So this is the formula for the percentage error. And to find the actual error, we have already found the absolute error to be 2.5. So we have to find the actual error. So it's very simple. We are given the base and the height to be 6 centimeter and 4 centimeter, as it is written here. So we say the actual error, which is the actual length, actual base and the actual height, area of a triangle is half base times height. So the actual base and the actual height will be 6 centimeter and 4 centimeter, and not this, because these are the error in the base and the height. So we say area is half times the base, which is 6, and the height, which is 4, and this will give us 2 here, this is 3, and everything here will give us 12 centimeter square as the actual error, which is the actual error of the area. So the percentage error is absolute error. The absolute error will be 2.5 divided by 12 times 100. If you do this in your calculator, you should get something like 20.83. Yeah, 20.83 in your calculator. So the question says we should be given, the answer should be given to 1 decimal place. So to 1 decimal place, so the answer will be 20.8 in 1 decimal place, and that will be the answer. If you've been following the solution, you can now solve this question. It is taken from UME 1988 question 3, and these are the options. Let me know your answer in the comment section, and don't forget to press the notification button. Thank you.